video on geometric sequences and how to calculate them. This is on page 6 of your notes. And we'll dive right in. What's a geometric sequence? It is, first of all, it's a sequence. And back in the day, we talked about what that means. A sequence is a number pattern. That's a sequence. But this is a special type of number pattern. It's geometric, and what that means is a number pattern that uses multiplication or division. All right, let's see if we can identify some. I'll just write down some number patterns, and then we'll talk for a second about if they're geometric or not. So the first one I have is 1, 2, 3, 4, 5, 6, so on and so forth. First question, is it a sequence? The answer is yes. There definitely is a pattern to these numbers. Second question, is it a geometric sequence? And the answer is no. And the reason is because the difference between this pattern goes plus 1, plus 1, plus 1, plus 1, plus 1. That's clearly not multiplication, so it's not a geometric sequence. All right, we'll look at the next one. How about if I go 3, 6, 12, 24, 48, like that. Question number 1, is it a sequence? Excuse me, the answer is yes. And now let's check to see if it's geometric or not. Well, to go from term 1 to term 2, that's times 2, times 2, times 2, times 2. So the answer is yes. This one is geometric because it uses multiplication from one term to the next. All right, let's try another. How about if I go 100, 50, 25, 12.5, and so on and so forth. Well, at first you're thinking, ooh, it's getting smaller, so I'm not quite so sure. But let's look at the pattern. Times 1/2 or divide by 2. Times 1/2, times 1/2, times 1/2. So because the pattern is times 1/2 or divide by 2, we're going to say yes, this one also is geometric. All right, there's two ways that we can write formulas for these. One of them is, well, okay, first of all, let's answer this question. What's the difference between arithmetic and geometric? Arithmetic, this is the old one that we use. This one uses addition or subtraction to make its pattern. Geometric uses multiplication. You might say or division, which I guess is fine, but I just call that multiplication by a fraction. The two ways that we can have formulas, the first way is recursively. So that means we have the swoosh bracket, if you remember. The first line gives the first term, which would be g sub 1. And then you would tell what that term is. And then here's how the next one goes. If you want to find more terms, that's going to be g sub n is equal to g sub n minus 1. If you remember, this symbol means the term before. And we're going to write times r. And this r is the ratio, the number that you're multiplying over and over and over again. So for this middle example, here the ratio would be 2, because it's times 2 times 2 times 2. Here the ratio would be 1/2, because it's times 1/2 times 1/2 times 1/2, like that. Recursive formulas are okay. They're easy to write, but the problem with them is if I wanted to find the 200th term, for example, I couldn't just jump straight to the 200th term. You'd have to start with the first term and then work your way up to get there. Hands down, the better one is the explicit formula. The explicit formula goes like this: Gn equals G1. So the term that you're trying to find is the first term times your ratio to the power of n minus 1. This is literal subtraction, so whatever number you plug, you're going to subtract 1. All right, let's try a few examples, and then we'll see what you can do. So for number 1 here, it says write the first 6 terms of a geometric sequence whose first term is -3. Okay, that's handy, so we know the first term. And whose constant ratio is 4. Oh, that means the multiplier is 4. So all I need to do is just go times 4. Times 4 should give me -12. Times 4 should give me -48. Oop, we're outside of what I can do in my head, so we'll go 48 times 4 is -192. Times 4 is going to be -768. Let's see, one more times 4 is going to be -3072, like that. If you notice, these numbers are getting really big really fast, and that's what geometric sequences will do. They'll start out with some manageable numbers, and all of a sudden, ooh, they really take off. If I want to give a recursive formula for this, that's the top one that I'm going to use here. First, we need the swoosh bracket, so we got the swoosh. In the first line, we're just going to give the first term, so we're going to say G1 is equal to -3. You just tell me what the first term is. And then the bottom one says, all right, these first two symbols never change. It's just Gn is equal to Gn minus 1, like that. And then you just write times your ratio, times your multiplier, which is times 4. And you're done. That's it. They're super easy to write. That's why we like them. Once again, the bad part about that formula is if I said find term 200, well, you'd have to get out your calculator and start pushing some buttons. The explicit formula, hands down, is the better one. And it looks like this. Gn is going to be equal to G sub 1, which would be -3, times 4, so because it says times the ratio right here, to the power of n minus 1, like that, and we're gonna leave it. A couple things about the formula. First of all, because of PEMDAS, because exponents comes before multiplication, we cannot combine these two. We cannot call this a -12. These need to be separate. The second thing is that this n, this is the term number that you want. So for example, let's say I ask you, hey, what's the 12th term? Well, all you'd have to do is plug a 12. So if I wanted to find the 12th term, it would look like this. G sub 12 is equal to the first term, which is -3, times the ratio, which is 4, to the power of the 12th term would be 12 minus 1, which is actually just 11, like that. So if I wanted to find the 12th term of the sequence, I could just go -3 times 4, like that, and then go power 11, because that's that 12 minus 1. Voila. It's a big number, but there it is. The nice part about this this explicit formula is that you can just plug in whatever term number you want and get it out. All right. Let's see. Pause it and see if you can do number 2. See if you can write out the first 5 terms of this next sequence. There's 2 things we could do for this one. The first thing I could do is just say, hey, here's the first term. First term's 4. I see it right in the formula. And I see that the pattern is 3. So times 3 is 12. Times 3 is 36. Times 3, 36 times 3 is going to be 108. And times 3 should be 324. And we're done. If I didn't want to use that, let's just say, hey, I didn't happen to recognize that this is the first term in the multiplier, and that didn't dawn on me. Here's what I could do. I could use this. If I want the first term, all you'd have to do is plug a 1. So let's try it. We'd go 4 times 3 power 1 minus 1, like that. And actually, let's make sure we put parentheses around that exponent. 1 minus 1, like that. So if I want the first term, just plug a 1, and what do you get? Hey, first term's 4, and I kind of knew that. If you try hitting second and enter, and whatever you typed in will just pop right up. Now let's say I want the second term. Well, just do 2. Now just plug a 2 because it's the second term. Okay, you get the next one. Second, enter. Plug a 3, the third term. You get the idea. Whatever term number you want, you can just plug that number in. All right, pause it again. See if you can look at this sequence, write a recursive formula, write an explicit formula. If we look at it, recursive formula means we have a swoosh. So we would say our first term is equal to 8. Looks like our next term is going to be equal to our previous term. And it looks like the multiplier here is going to go times a half, times a half, times a half. So I'm going to go times 1/2, like that. If you put divide by 2, I suppose you're right. But it's just easier to write multiplication, I think, than division. The explicit formula then would just be Gn is equal to your first term, which is 8, times 1/2 power n minus 1. And you got it. All right. Now, look at number 4. See if you can read that story and write an explicit formula. So a formula that looks like this that matches this formula right here. When I look at this, here's a couple things that come up. Some common things, places where people mess up. The word depreciates means it loses its value. So 20%, if it depreciates by 20%, it means that it loses 20% of its value, but it keeps 80%. So if I'm trying to write this, the question says, how much will this car be worth in 8 years? Here's how I often see people fill this out. They say, all right, well, my first term is going to be 14,000. And then 20%, well, that's 0.2 to the n minus 1, and times 0.2 to the n minus 1, like that, and then they just plug in an 8 and solve the problem. Well, there's a couple things that are wrong with that. First of all, here's the easiest one to see, is that I'm losing 20%, but the question asks me how much will it be worth. So that means I want to calculate not how much I lose, but how much I keep. So if I lose 20%, that means that I keep 80%. So the better way to write the formula is going to be 14,000 times, not 0.2, but times 0.8, because I'm keeping 80% of my value, power n minus 1, like that. All right. That fix, I think, makes sense. Here's the trickier fix, the one that I think is harder to understand. If we're finding term numbers, the 8th term should be when 8 years have been completed, and that makes sense. So if I want to find it after 8 years, I'm just going to plug in 8 and be done with it. The 7th term, then, would be when 7 years are completed. The 6th term when 6 years are completed, and so on and so forth. In our formula, this right here, this number is G sub 1. And what that number should be, the number that's here should be the number when 1 year is complete. And that's where we're coming into some troubles here. This 14,000, this is not G sub 1. This is not when 1 year is complete. This is the beginning. This is G sub 0. That's when 0 years are complete. So this is a fix that we need to make. So the formula does not have G sub 0 here. It has G sub 1. So what we need to do is have 1 year go by in order to find G sub 1. So I'm going to go G sub n. If a year goes by, I need to take 80% of this because it's lost 20% of its value. So I'm going to go 14,000 times 0.8. So after 1 year, my car is only worth $11,200. That's term 1. The multiplier is still 0.8 to the power of n minus 1, like that. Now I have my formula. Here's G1, here's my multiplier. And now I can just plug in an 8 and be done with it. I can go 11,200 times 0.8 power. If I want 8 years, 8 minus 1 is 7. So I can just go like that. So $2,348.81. $2,348.81. That's not the only way to fix this formula. It's the one that I think makes the most sense. If you have a different way to fix this problem of this being the wrong number, go ahead.